click, off, click your nitrile gloves. Discharge. Hello and welcome to StarBorn Science. Today we will be preparing a coordination compound of copper with ethylenediamine. It's an energetic compound, so we will take care preparing it and handling it. But first, because I wanna be working with pure reagents, I'm gonna start by filtering my copper perchlorate, because I want it as pure as I can have it, especially when it comes to energetics. You do not want contamination. So graphite filtration will do with this one. So, as it's filtering, let me show you its structure. Ethylenediamine is a bidentate ligand. It binds with two nitrogens on the copper, and two molecules of ethylenediamine coordinate with the copper atom. So as you can see, ethylenediamine is basically an ethane chain with two nitrogens. It's a D-amine. It has two amine groups. This corner you can see over here, these are carbons, and these are the amine nitrogens, which are bound to copper in this cage-like structure. And this is the perchlorate counterion, which of course we have two of them, since the copper has a +2 charge and these have a -1 charge. Now I've added also the hydrogens, so you can see it more whole as it actually is. I didn't want to add them in the beginning in order not to confuse you. So that's how it actually is. And there are also two water molecules coordinated to the copper, but I'm not gonna add them because they don't actually fit over here. But yeah. So this reagent now is prepared and very clean. Now I'm gonna prepare my ethylenediamine solution. I'm gonna prepare a 50% aqueous solution. Because I do not like handling anhydrous ethylenediamine, because it's very reactive. So there you go, 25 milliliters of that. and 25 milliliters of distilled water to bring it to 50%. So now I got our two reagents ready, so I'm gonna pop a stir bar in and add copper perchlorate. Since this is a bit concentrated, I'll also dilute it a bit. And while it's stirring, I will start adding the ethylenediamine drop-wise, and you'll notice the color change as the complex is forming. And the solution will heat up significantly during this phase. And it will turn a violet color, which I don't know that if my camera will pick up, but it's a deep violet color, and that should do it. And we're gonna keep stirring for a bit. And now I will stop stirring and fish out the stir bar from the solution. And take the solution with our complex in, which is hot to the touch and probably over 50 degrees Celsius. As you can see, the condensation over here on the walls of the beaker, and put it in the freezer and precipitate our complex. So after a while in the freezer, a mass of purple crystals has precipitated. So I'm gonna go ahead and filter it out. And then I will proceed to wash the crystals with cold ethanol. Remove most of the remaining water and ethylenediamine. And now that that's done, I'm gonna spread the crystals over here, dry. Using a glass rod. I'm using just mild heat, like 50 degrees Celsius. Don't wanna boost it and cause them to explode or anything. Because as I said, this compound is energetic. And when it dries, I'll be back. Found very nice crystals. They're almost dry already due to the ethanol wash. Took away most of the water. So as I said, this compound is energetic. So now it's dry, as you can see. And I'm gonna bottle it up and do some tests with it. And there you go. Now this is good and all, but energetically this complex suffers from a very low oxygen balance, meaning these perchlorate ions do not have enough oxygen to fully oxidize these carbon ligands. So what we're gonna do to fix this is add an oxidizer. In this case I've chosen potassium chlorate. So now I'm gonna show you the oxygen balanced version. Now this is the oxygen balance version made by adding 46% by mass potassium chlorate. As you can see, this is a lot more energetic. Now I'm gonna do an impact test. I have to note that this compound, this mixture of compounds, is a primary high explosive. So be extremely careful with it. Now, as promised, I'm gonna perform a test of the oxygen balanced version, and that's about 50 milligrams because I don't want the cops called on me. So, note that this is the oxygen balanced version. The normal version will not detonate when struck with a hammer. Any mixture that reaches to zero oxygen balance will become more sensitive and more easily detonatable. So yeah, there you go. So that was all from me. Next video is gonna be about the bromination of trinitrophenol. Subscribe and stay tuned in order not to miss this. Keep dreaming, keep exploring, and I will see you on the next one. Thank you.